Somewhere in China, workers are feeding dead electric car batteries into a factory, and almost nothing inside them is going to be thrown away. Not the lithium, not the nickel, not the copper. The battery gets torn down until what is left is a dark gray powder, and that powder is worth more per ton than most of the rock coming out of an actual mine. A few hundred kilometers away, a solar panel that spent its whole life bolted to a roof is being pulled apart on purpose. Glass on one pile, aluminum on another, and a trace of silver so small you could not see it that is worth more than everything else in the panel combined. And in a third place, a building that took 2 years to construct is being crushed into gravel, and that gravel is going straight back out the gate to become a road. Here is the strange part. None of this is happening because somebody wants to be green. It is happening because a country that builds more batteries, more solar panels, more phones, and more buildings than anyone else on Earth is about to have to take all of those things apart again. And it has quietly decided that is a business. This is real. It is happening in 2026, and by the end of this video, you will understand how a dead battery, a demolished apartment block, an old shirt, and a bucket of rotting food are being pulled into one enormous industrial machine, and why the government has just put a price tag on it that is measured in trillions. If that sounds like an exaggeration, stay with me because the number is public, and I will show you exactly where it comes from. Before we go further, if you like videos that show you the parts of the story nobody else bothers to explain, hit that like button. It costs you nothing and it genuinely decides whether this channel keeps going. And subscribe because it really makes my day and a sign that you are interested in this topic and want the world to be free from every type of waste. Let's get into it. The mine hidden inside a battery. Look at a battery pack pulled out of a scrapped electric car. It looks like a heavy black slab, dead weight, useless. It is not useless. Depending on what chemistry it was built with, it contains lithium, nickel, cobalt, manganese, copper, aluminum, iron, phosphate, and graphite. Those are exactly the materials that every car maker on Earth is currently scrambling to secure, and they are sitting there in a shape somebody already refined and assembled for you. So, what actually happens to it? First, it gets collected, identified, and inspected, and then the remaining charge has to be safely dealt with. This part is not optional, and it is not easy. A partially charged lithium battery that gets crushed is a fire. Then it gets checked to see whether it still has a second life. A pack that can no longer push a car up a hill might still be perfectly capable of sitting in a shed and storing solar power overnight. That is worth doing, but be clear about what it is. That is reuse. It delays the problem. That battery still has to be recycled eventually. For the rest, the pack gets dismantled into modules, then shredded and mechanically separated. Metals, plastics, and casing come off, and what is left is a fine, dark powder called black mass. Black mass is the whole point. It is the concentrated electrode material, and it holds the nickel, cobalt, manganese, and lithium in a form that chemical or thermal processing can pull apart into battery-grade compounds. Those compounds go back to a cathode factory. That is the loop closing. Here is where the scale gets hard to argue with. Analysts consistently put China at somewhere around 70% or more of global battery recycling capacity, and by some measures, close to 80% of the world's capacity to do the shredding stage and nearly 90% of the refining stage. This is not a country dabbling, this is a country that owns the infrastructure, and it has been building the legal plumbing to match. China's first national standard for black mass took effect on July 1st, 2025, and from August 1st, 2025, black mass, meeting that standard, stopped being classified as solid waste, which means it can be imported freely. Read that again. While Europe was tightening up and treating black mass as hazardous waste that mostly cannot be exported, China was writing a rule book that lets the stuff flow in. To be fair, this is nowhere near as clean as it sounds. Different chemistries need different processes, and they are not equally worth doing. An NCM battery is full of nickel and cobalt and is genuinely valuable. An LFP battery is cheaper, which is great for the car buyer and awkward for the recycler, because there is much less money sitting inside it. And here's the part the industry does not put on the brochure. China's licensed, regulated battery recyclers have been running at somewhere around 20 to 30% of capacity. Not because there are no batteries, because unlicensed backyard workshops with no compliance costs can outbid them for the feedstock. The country built the factories, the batteries went somewhere else. So the machine is real, and the machine is enormous, and the machine is half empty. Batteries at least contain enough value to justify all of that expensive equipment. The next material is harder precisely because it is worth almost nothing. The plastic that normal recycling cannot handle. A clean plastic bottle is an easy problem. One polymer, no contamination, uniform. You sort it, wash it, shred it, melt it, reform it. Done. Now, picture a crisp packet. It is plastic bonded to a metallized layer, bonded to a printed layer, held together with adhesive coated in grease. There is no machine that separates that cleanly because the entire packet was engineered specifically so that its layers would never separate. That is the real plastic problem, not bottles. Multi-layer packaging, films, food-contaminated wrapping, mixed polymers, composites, black plastic that optical sorters physically cannot see, plastic glued to paper or foil. Mechanical recycling handles the easy stuff, and it handles it well, but quality tends to slide with each pass, and it falls apart entirely when the stream is dirty or mixed. So, the other route is chemical. Break the plastic down to smaller molecules, oils, monomers, chemical feedstock, and rebuild from there. Pyrolysis, depolymerization, solvolysis. These are genuinely different processes with genuinely different outputs, and it is worth being suspicious of anyone who talks about them as one thing. And here is the honest tension. Chemical recycling can eat material that mechanical recycling cannot touch. It also tends to want a lot of energy, careful sorting, and expensive plant. And some of what comes out is a fuel or a chemical feedstock, not a new bag. That is not nothing. It is also not the same as making plastic into plastic again. Now, the history here is genuinely important, and most people have it backwards. For decades, China was the world's plastic recycling system. Since reporting began in 1992, it took in around 106 million tons of plastic waste, close to half of everything traded globally. Europe and North America put their yogurt pots in a bin and shipped them across an ocean. And the awkward reality is that this was never mainly an environmental favor. It was raw material for factories. Then, in January 2018, National Sword landed. China banned 24 categories of imported waste and dropped the allowable contamination limit to a level so low it functioned as a ban outright. Plastic imports fell by 99%. Researchers at the University of Georgia calculated that roughly 111 million tons of plastic waste would be displaced by that single policy through 2030. Recycling programs in the United States were canceled. Britain burned more. Southeast Asia got buried in bales it never asked for. The world found out that its recycling system had been one country, and that country had just closed the door. And that is the point. The ban was not only about pollution. It forced China to build a domestic collection system because the factories still needed feedstock and it was not arriving by ship anymore. Mixed plastic is hard because its materials refuse to come apart. The next material is hard for a much more insulting reason. Somebody bonded it together deliberately and engineered it to stay bonded for 30 years outdoors. What happens when clean energy becomes waste? Nobody wants to talk about this one because it spoils the story. A solar panel is a climate solution right up until the day it becomes 20 kilograms of laminated composite that nobody has a plan for. Inside it, there is glass and aluminum frame, copper wiring, a junction box, silicon cells, encapsulating polymer, a backsheet, and a small amount of silver. By weight, it is boring, about 2/3 glass, about 1/6 aluminum. But look at the value instead of the weight and it flips completely. The silver in the cells accounts for more than 60% of the economic value of the whole module. The rest is bulk. The process in principle is straightforward. Take the module, pull the aluminum frame off, remove cables and junction box, recover the glass, which is most of the mass. Then, use mechanical, thermal, or chemical processes to break apart the bonded layers and recover silicon, copper, and the silver where it makes technical and economic sense. That last clause is doing an enormous amount of work, because here is the problem. Everything in that panel was laminated together specifically so that 30 years of rain, hail, frost, and UV could not get in. You are trying to undo on a factory line at a profit the exact thing the engineers spent decades perfecting. So, a lot of panel recycling in practice is frame and glass. The frame comes off easily, the glass is heavy. The silver, the thing that is actually worth the most, is the hardest part to get to, and the wave is coming regardless. China's Photovoltaic Industry Association expects retired panels to hit around 18 gigawatts by 2030, roughly 1.4 to 1.5 million tons. By 2040, cumulative waste could reach 253 gigawatts, in the region of 20 million tons. Not because the panels are bad, because China installed a staggering number of them and they are all aging on roughly the same schedule. A solar panel is hard because everything is fused. The next one is hard for the exact opposite reason. It arrives as millions of unrelated fragments, and there are more of them than anything else on this list. The city rebuilt from its own ruins. Forget batteries for a second. Forget solar. By sheer tonnage, this is the biggest waste stream in China, and it is not close. When a building comes down, what is left is concrete, rebar, structural steel, brick, asphalt, glass, timber, gypsum, soil, stone, ceramics, insulation, and a lot of unidentifiable mixed debris. The process is brutally simple compared to everything else you have seen. Waste arrives from the site. Anything large and reusable gets pulled out first. Metals get taken by hand or by magnet. Concrete, brick, and stone go through crushers. Screens sort by particle size. Air or density separation blows out the light contamination. What is left is recycled aggregate, and it goes into road bases, fill, blocks, and some concrete applications. The steel goes back into the metal system where honestly it has always gone, because steel has been worth money forever. No exotic chemistry, no black mass, just crushing. And yet, in 2020, China generated in the region of 2.6 billion tons of construction and demolition waste. Of that, roughly 312 million tons were recycled. That is about 12%. The overall comprehensive utilization rate for this stream sits under 40% by most assessments, and a lot of cities are still relying on scattered landfills. For comparison, the United States generates far less of this stuff and recovers something like 75% of it. Chongqing alone produced 167 million tons of construction waste in 2021, which was more than half of all the solid waste in the city, and it was recovering under 30%. So, why is the easiest process on this list also the worst performing? Money. Crushed aggregate is cheap. Sending a truck to a landfill is cheaper still if the landfill fee is low, and for a long time it was. The technology was never the bottleneck. The economics were. And the quality issue is real. Recycled aggregate depends entirely on what went into it. Contaminated demolition waste from an uncontrolled site is not the same material as clean, separated waste from a managed one, and a lot of it is genuinely not suitable for structural concrete. You can crush anything. Getting something back that an engineer will sign off on is a different job. Construction waste hides its value in enormous quantities. The next stream hides it in pieces smaller than a grain of rice. The urban mine inside old electronics. Here is a number that reframes the whole category. A ton of ore from a gold mine might contain a few grams of gold. A ton of circuit boards can contain vastly more, which means the richest gold deposit near a Chinese city is not underground. It is in a drawer, in a warehouse, in a pile of dead phones. That is what people mean by urban mining, and it is not a metaphor. It is a statement about concentration. Electronic waste means phones, computers, circuit boards, televisions, fridges, washing machines, electric motors, cables, screens, servers, telecoms gear, and inside it is copper, aluminum, steel, gold, silver, palladium, plastics, glass, and depending on the device, rare and specialty metals. The process goes like this. Collect and categorize. Pull out the batteries and hazardous components first, always. Separate anything reusable. Then dismantle by hand or shred. Magnets take the ferrous metals. Eddy currents take selected non-ferrous metals. Optical, density, and electrostatic systems split the rest. Then, smelting or hydrometallurgy pulls out the metals themselves. Whatever is left needs treatment or disposal, and there is always something left. China has been formalizing this hard. Between 2024 and 2025, it brought roughly 53 million used home appliances and mobile phones into standardized dismantling channels, growing at around 12% a year. A single licensed plant in Fujian handles more than 2,000 discarded appliances a day. A fridge goes in one end and comes out as separated plastic, metal, and foam, each on its own path. Electronics at least contain metals worth chasing. The next material is the hardest yet, because the valuable part is cheap, dyed, and glued to 5 other things. The shirt that refuses to dye. Pick up a shirt. Look at the label. If it says 100% cotton or 100% polyester, you are holding a solvable problem. If it says 60% cotton, 35% polyester, 5% elastane, and it has a printed graphic, a coating, a zip, buttons, and dye, you are holding something that essentially no process on Earth can turn back into an equivalent new shirt. That is textile recycling in one sentence. Purity is everything, and modern clothes are engineered to be impure. The waste comes from factory cutting scraps, unsold stock, worn clothing, uniforms, shoes, and the roots out are wildly unequal in value. You can resell it or repair it, and that is reuse, which is the best outcome and the one nobody makes a documentary about. You can turn it into industrial wiping cloths. You can shred it mechanically into shorter, weaker fiber and use it for insulation, stuffing, or cushioning. Or you can chemically break down selected synthetics and rebuild them into fresh feedstock. Those are not the same thing, and it matters enormously which one you mean. Shredding a shirt into loft insulation is recycling. It is also a one-way trip downward. The shirt is never coming back. Chemically cracking polyester into its building blocks is the genuinely interesting route, and China is doing it. A company in Zhejiang, GRN New Materials, is producing recycled DMT, one of polyester's chemical building blocks, at purity up to 99.9%, with a green recycling project running at 50,000 tons a year of capacity and regenerated fiber output projected to reach 500,000 tons by 2030. Now, put that against the size of the pile. In 2020, China produced around 22 million tons of textile waste and was recycling roughly 20% of it, yielding about 1.5 million tons of recycled fiber. In 2022, the National Development and Reform Commission and 2 other ministries set the targets: 25% recycled and 2 million tons of recycled fiber by 2025, then 30% and 3 million tons by 2030. Look closely at those numbers. The most ambitious official target on the table is 30%, which is an admission. Even the plan assumes that 7 out of 10 discarded garments are not coming back. Clothing can sit in a warehouse for a decade and nothing much happens. The next material starts destroying itself within hours, and that turns out to be the useful part. The power plant inside a trash bin food waste is the one everybody underestimates, and in China, it is not a side stream. In a city like Shanghai, wet waste has historically been around 60% of household waste. It is also the single worst thing you can mix into everything else. It is heavy, it is wet, and it contaminates every dry recyclable it touches. Water in the bin also drags down the calorific value of everything you might want to burn later. Food waste is not just its own problem, it is the thing that breaks the other solutions. But separate it out and the physics gets friendly. Anaerobic digestion works like this. Organic waste goes into a sealed tank with no oxygen. Microorganisms break it down. That produces biogas, mostly methane and carbon dioxide, which can be cleaned and burned for heat or electricity or upgraded into fuel. What is left, the digestate, can be processed toward fertilizer or soil use where it is safe and legally allowed. That last clause is doing real work again. Digestate and sewage sludge can carry pathogens and heavy metals. Nothing about coming out of a digester makes something automatically safe to put on a field. And salt is a genuine, unglamorous problem. Chinese kitchen waste is salty, and salty compost is not much use, which is one of the reasons capacity here grew more slowly than the sorting did. Which brings us to the moment the whole thing changed. On July 1st, 2019, Shanghai made household waste sorting mandatory by law. 4 bins: household food waste, recyclables, hazardous, residual. Individuals could be fined up to 200 yuan for getting it wrong, companies up to 50,000. The city has more than 24 million people and generates around 30,000 tons of household waste a day. People hated it. It trended on Weibo as a joke about residents being driven insane. And then it worked. Sorted food waste went from around 4,000 tons a day to a stable 9,000 to 10,000 tons a day. Not 20% better, more than double. And the separated food waste came out at 99.5% purity, which is the number that actually matters, because a digester full of plastic bags is a broken digester. Recyclables collected rose sharply, hazardous waste collection went up by a factor of more than 10, and residual waste dropped by around 20%. Because the wet stuff was gone, the calorific value of what was left nearly doubled, which made the residual waste dramatically better to burn. That is the lesson hiding in this chapter, and it is not about biogas. The most powerful piece of technology Shanghai deployed was a law that told 24 million people which bin to use. But even after all the reuse, all the sorting, all the recycling, and all the digesting, there is still a pile left over. And what China does with that pile is the most misunderstood part of this entire story. The waste that cannot yet be recycled. Let's be precise, because this is where the story usually gets sold to you dishonestly. Burning trash is not recycling. It is waste treatment with energy recovery. It reduces volume, it produces electricity and heat, and you can pull some metals back out of the bottom ash. It does not return materials to production. A plastic bottle that goes into an incinerator is gone as a bottle forever. With that said, look at the scale, because it is genuinely extraordinary. By the end of 2024, China had 1,129 waste incineration plants in operation, with installed waste-to-energy generating capacity of 27.38 gigawatts, producing about 145.3 billion kilowatt-hours of electricity. Total design treatment capacity is over 1.1 million tons a day. Research published in Nature Communications found these plants supplied up to 7% of China's residential electricity consumption in 2023. Incineration became the dominant method of treating household waste.